Hey guys, and welcome back. Today we're going to do a quick chapter review for chapter 5 in our Florida Best Mathematics book. We are going to review on our understanding of factors, multiples, and patterns. We're going to review on finding the factors of a number, explaining the differences between factors and multiples, and use our divisibility rules to tell whether or not a number is prime or composite or neither. And let's not forget those rules that we also use to determine and to make number patterns. Now, our lesson was 5.1. It was understanding factors. So we're starting with the factor of 6 for question 1. Use the rectangles to find the factor pairs for 6. Now, we always start with 1 times the number itself. The number 6 is even, so it's going to be a 2 times 3. Now, those are our divisibility rules. Now, right now, I have to think, does anything else give me 6? And it does not. So for number 6, we only have two factor pairs. We have 1 and 6, and then we have 2 and 3. Now, if we were to plug those into the array, it would look like this. 1 and 6 for this array, and 2 with a 3 on top for the second array. So in this case, this number, 6, is a composite number because, again, there's more than one way to get the multiple of 6. In other words, there are two factor pairs for 6, 1 and 6 and 2 times 3. Now, let's go on over to lesson 5.2. That lesson was on factors and divisibility. Use division to find factor pairs. Find the factor pairs for the number. Factor pairs are, remember, the numbers that you multiply together to get the multiple. So this one is 16. We always start with 1 times the number itself. 1 times 16. 16 is a even number, so it's going to be 2 times 8. 1 plus 6 is 7. 7 is not divisible by 3 based on our divisibility rules, so it's not 3. But I do know that 4 times 4 will also give me 16. Now, here I have 3 different factor pairs for 16. And of course, we know it's not divisible by 5 because, again, there's a 6 in the ones place. And we're going to go ahead and stop at 8 because it's already there. That's why I underline the 8. Now, let's write those factor pairs. We would write it as 1 and 16, 2 and 8. And then our last one would be 4 and 4. So 16 has 3 factor pairs. That means 16 is a composite number because there's more than 3 different possible arrays that I can make to do 16. Now, if we look at number 5, 56, the multiple, we start with 1 times the number itself. It's an even number, so 2 times 28 gives me 56. Now, 5 plus 6 is 11, so that's not divisible by 3. If I go to 4, well, 56 is an even number, so I know that 4 times something is going to give me 56. Now I just have to figure out what the something is. In order to do that, let's use this strategy. Let's see, 2 boxes on top, number I don't know, but I do know that the multiple, the product has to be 56. So let me look at the ones place. What number times 4 will give me a ones place of 6? It would be 4 because 4 times 4 is 16. I carry the 1. Now, if I multiply 4 times 1, which is 4, plus 1 is 5, I get 56. Therefore, 4 times 14 as the other factor does give me the multiple of 56. Now, 56 is not divisible by 5 because it ends in 6, not 0 or 5. 56, then we would go into if it's divisible by 6, but if it's not divisible by 3, it's not divisible by 6. But knowing our multiplication facts, we know that 7 times 8 is 56. So here I have, as a factor pair, 1 and 56. I have 2 and 28. And then I also have our factor pairs, the remaining factor pairs of 4 times, or 4 and 14 is the third factor pair, and 7 and 8 is the last factor pair. So 56 has 4 factor pairs. That means that the number is a composite number, not a prime. Now, let's take a look at list of factors of a number. Remember, what are factors? Factors are the numbers you multiply together to give me the multiple. So in this case, I'm looking at number 7. The multiple is 60. 1 times 60, it's an even number, so 2 times 30 is 60. 3 times 20 is also 60. And I know it's an even number. So if it's also divisible by 2, it's going to be divisible by 4. That means I would have to think 4 times what number will give me 60. So you need to think, do you know what number times 4 gives me 60? Well, if you guess 15, let's try it out. 15 times 4, 20, carry the 2. 4 times 1 is 4, plus 2 is 6, right? So it was 4 times 15 is 60. 60 ends in 0, so it's 5 times 12. It's divisible by 5. It's also divisible by 6 because it's divisible by 3. 6 times 10 is also 60. Now, I need to list the factors. And the other ones, I listed the factor pairs. Now, I just need to put all these numbers in order. I start from the 1 on the top and I work my way around all the way back up to the 60. Kind of like a turn. I'm turning it around. So I go ahead and I start writing the numbers in order. 1, 2, 3, 4, 5, 6. The next number after 6 in order is what? Right, 10. Then keep going up in that order. 12, 15. Then I have 20. Then I have 30. And finally, I have 60. These are all the factors of the number 60. Now, remember also that 60 is a multiple. So the numbers that we put are factors. Those are the numbers that we need to multiply together to give me that amount. So now that we went ahead and did that, let's take a look at question 9. Going back to those divisibility rules, how do I know if 3 is a factor? Well, 5 plus 6 is 11. 11 is not divisible by 3. So 56, I cannot divide 56 by 3. If I did divide 56 by 3, it gave me a fraction. It would give me a remainder. So no. Now I know that 2 plus 1 is 3. 3 times 7 is 21. I also know that 3 times 12 is 36, because 3 plus 6 is 9. So that's also divisible by 3. Let's look at 4 plus 8. 4 plus 8 is 12. So that's divisible by 3. I just have to figure out 3 times what gives me 48. Well, let's say I don't know. I'm going to go ahead and divide 48 divided by 3. How many times or how many 3's can I fit in a 4? 1. 1 times 3 is 3. I subtract, which is 1, and I bring down. Division starts all over again now. 18 divided by 3 is 6. 6 times 3 is 18. I know I'm not going to have a remainder, so there you go. 3 times 16 is 48. Remember, you could always multiply your quotient times the divisor, which is 3, and you will get the dividend, which is the number inside. 9 plus 3 is 12. We know that's divisible by 3, and that gave me 3 times 31. So that's divisible by 3. If I look at 7 plus 1, that equals 8. 8 is not divisible. I cannot divide 8 by 3. I'm going to get a remainder. So my answer is no. 3 is not a factor of that number. Now, let's review lesson 5.3. Relate factors and multiples. Now, we're trying to determine if a given number is a multiple of another number. Let's look at number 11. Remember, the word multiple, and I underlined it, is another word for product, right? For product, right? So I need to find if 45, if I can evenly divide 45 into 7. In other words, if I were to look at my 7 times tables, will I get a 45? Let's say you don't know. What you're going to do is you are going to divide. You can always divide 45 by 7. So the answer in this case is going to be a no. Now, just like I said, if I divided 45 by 7, I get 6 remainder 3. So in this case, it is not divisible by 7 because I have the remainder of 3. If I have a remainder, I definitely have to say that no, that number is not divisible by 7 because again, I have a remainder. So since it doesn't have a remainder, I can always check again. Let me rectify that. I can divide 45 by 7. I know that 7 times 7 is 49. So I can't use 7. I'm going to go ahead and use 6. 6 times 7 is 42. I do 42. I subtract that from 45. And again, just like I was explaining, I now get remainder 3. So in other words, is 45 a multiple of 7? No, it is not a multiple of 7 because it is not divisible by 7. Why is it not divisible by 7? Because just like I said before, I have a remainder. If a number is going to be divisible, I will not have a remainder. I will have an even number, no remainder. If you have a remainder, really a remainder is like a fraction of that number that's left over. So that means that no, it would not be divisible by that number. So if we move on over to lesson 5.4, we're looking at identify prime and composite numbers. Remember that prime is only one way to get that number, 1 times the number itself. And then the word composite means plus 1. In other words, more than one way to get itself. So prime is one array, composite is more than one array. So for the number 51, I know that I always start with 1 times itself. It's an odd number. It's not divisible by 2, but it is divisible by 3 because 5 plus 1 is 6. I just have to figure out 3 times what number gives me 51. In that case, we have 17. 3 times 17 is 51. Now, I only have 2 possible arrays for 51. If I have more than one, it is considered a composite number, not a prime. Remember, composite number means more than one. More than one array. I can make more than one different array to show that specific multiple. Now, let's take a look at number 15. If you remember my lesson from before, I had said a specific rule for determining the number 1. I also said another specific rule for determining the number 0, whether or not 1 and 0 are either prime or they are composite or they are neither. Now, in this case, look at number 15. The number is 1. Now remember, in order for me to get a 1, I can't really multiply it times any other number other than itself. 1 times 1 is 1. If I look at a 0, for example, I'm always going to have the multiple of 0. 0 has no multiples. It's 0. So 1 times 1 is equal to 1. So there's no other factor. It just has one factor. The only factor of 1 is 1. Therefore, it's not a prime or a composite number. And then the number 0 is the same thing as I just explained. So 0 or 1 are neither. Again, they are not prime, they are not composite. They're neither for the reasons that I explained. Now, if we look at number 16, we have 83. So I know that my divisibility rules, I always start with 1 times that number. That's 1. 83 is an odd number, so it's not divisible by 2. 8 plus 3 is 11. 11 is not divisible by 3. It's not an it's an odd number. If it's not divisible by 2, it's not divisible by 4. If it's not divisible by 3, it's not going to be divisible by 6. So that means there's only one possible solution. And that fact is that 83 is prime. There's only one solution for 83, 1 times that number, and that's it. That means that 83 only has two factors, 1 and itself. That's what makes the number prime. Okay? So if I look at number 17 on lesson 5.5, I'm going to follow those rules. Remember those rule patterns that we were discussing? So for example, if I have the rule is to add 8 to every number, right? So again, I start with 15. Great. 15. So you go ahead and try it on a separate sheet of paper. If I have 15 and I add 8 more, what do I get? 23, right? 23 plus 8 more, I get 31, correct. 31 plus 8 more, I get 39. And 39 and 8 more, 47, right? And if I continue that pattern, I can keep going. 47 plus 8 more, right, 55. So that means that that's the rule that I'm following. Every number is 8 numbers more than the number before it. That's why the rule is add 8. Now, if I look at number 18, that one's a little trickier. You're going to have to divide. I start with the number 4096. You can go ahead and try that out on a separate sheet of paper. So I started off with 4096. And I need to divide by 4. Well, if I can't do this in my head, I'm going to have to do it this way. If I do 4096 divided by 4, then 4 goes into 4 once. 1 times 4 is 4. I subtract, which is 0. I bring down 0. Can I divide a 4 into a 0? Absolutely not. So it's 0. 0 times 4 is 0 again. I'm just going to go ahead and bring down that 9. 9 goes into 4, or 4 goes into 9 twice. That gives me 8. 9 minus 8 is 1. And I bring down the 6. Now, 16 divided by 4 is 4. 16 minus 16 is 0. I didn't, put it there, but you're not going to have a remainder. It's going to be 1024. Now, I have 1024. Guess what? My pattern starts all over again. So I have to get 1024, and I need to divide that by 4. So I'm going to go ahead and start with the second digit. Well, I'm going to make that, in other words, the first 2, 10. 10 divided by 4 is 2. That's how I got the 8. I subtracted that. It brings me 2. I bring down the 2, get 22. And then again, I have 5 times 4 is 20. Subtract that, I get 2. Bring down the last 4. I get 24. And I know that 4 times 6 is 24. If I were to put a 24 down at the bottom, it would be 24 minus 24, which again, remainder is 0. So 256 is my quotient. Now, I have to keep going. Now I'm going to get the number 256, and then I would go ahead and I continue working on that pattern. All right, guys, so I hope that helped. That little quick chapter 5 review we went ahead and did today on the Florida's Best Mathematics book. Remember to always stay tuned to my channel. Make sure you subscribe so that way you can stay up to date with any help or anything that you may need on any of the topics that I cover, that I cover in my channel. Thank you so much for watching and hope you have a great day.